Welcome to The Explainer. Today, we're going to dig into a single research paper, one with a deceptively simple title that just sort of appeared online one day and ended up completely changing technology as we know it. This isn't just some dusty academic paper, you know. This is basically the birth certificate for modern AI.
Yep, that's it. That's the whole title. And you should just let that sink in for a second. 8 words, but somehow packed inside those 8 words was a multi-billion-dollar revolution. It sounds more like a mantra from a self-help book than a scientific paper, right? But the ideas behind this phrase, well, they're the engine that's powering almost all the AI tools we use every single day.
And here's the thing, this paper didn't debut in some glossy journal with a big press tour. Nope, it was just quietly uploaded to an online archive. But its impact was anything but quiet. It was immediate, it was explosive. This document literally became the blueprint for a whole new era of artificial intelligence.
Okay, so let's really get into it. Let's trace the journey this thing took, from being just another online submission to becoming an absolute cornerstone of computer science.
So picture it, June 12th, 2017. 8 researchers hit submit. And over the next few years, the entire academic world is just buzzing. They're revising it, they're debating it, they're trying to wrap their heads around what it all means. And now, it's not just a paper, it's the paper. It's pretty much required reading for anyone who wants to build the future.
And its influence isn't some abstract thing. You can actually see it all over the web. We're talking more than 100 blog posts breaking it down, countless academic citations, but here's the really important part. It's the foundation for code that developers are using right now on sites like Papers with Code and Hugging Face. This is where theory became reality. This paper didn't just sit in a library, it got out there and built stuff.
But to really get why this paper was such a lightning strike, you have to understand the problem that everyone was stuck on. We need to kind of step back and ask, what did the world of AI even look like before this happened?
This was the frontier at the time. The big, hairy challenge for AI researchers was something called sequence transduction. Now I know, it's a mouthful. But really all it means is taking a sequence of things, like a sentence in one language, and turning it into another sequence, like that same sentence in another language. Think machine translation. The models they had were powerful for sure, but they had a really fundamental problem.
So the old way used these things called recurrent networks. Imagine trying to read a long book by looking through a keyhole. You see one word at a time, and your brain has to struggle to remember everything that came before. It's sequential, and because of that, it was painfully slow and really expensive to train. The new idea, the transformer, was completely different. It didn't use a keyhole. It saw the entire page at once. It could look at a whole sentence and weigh the importance of every word against every other word, all at the same time. It worked in parallel, not in the straight line.
And that right there brings us to the central game-changing idea. See, the authors didn't just tweak the old models. They didn't just give the old car a new coat of paint. They threw the whole thing out and started over with something that was amazingly much simpler.
In their own words, right in the abstract, they proposed a new, simple network architecture. They called it the transformer, and it was based only on a concept called attention. It got rid of all that slow, clunky, one-word-at-a-time stuff completely.
The pure elegance of it was its simplicity. They weren't adding more bells and whistles, they were taking things away. And that brings us right back to that audacious title, their main claim, that to understand language and context, all a model really needs is the ability to pay attention.
But you know, a bold claim is one thing. Proving it is something else entirely. So the researchers had to show that their new, simpler, faster model wasn't just a clever theory. It had to perform. So they took their new transformer model and entered it into what was basically the Olympics for machine translation, the WMT 2014 benchmark tests. This was the gold standard for measuring how well an AI could translate. So the big question was, how is this new architecture going to stack up?
So on the English to German task, the best models out there were hitting a quality score of about 26.4. The transformer came in at 28.4. Now I know, a 2-point jump might not sound like a lot, but in this field, that is a massive leap forward. It's a clear signal that something really special has happened.
And then came the English to French results. The transformer didn't just beat the old record, it absolutely shattered it. It set a new state-of-the-art score of 41.8. This was the mic drop, undeniable proof. The new, simpler model wasn't just as good, it was significantly better.
And here's the kicker. Not only was it more accurate, but it got these incredible results, and I'm quoting directly from the paper here, in a small fraction of the training costs. So it's better, it's faster to train, and it's cheaper to run. In the world of technology and business, that is the holy trinity.
So why does a machine translation breakthrough from 2017 matter so much to us today? Well, because the principles that made the Transformers so great at translation, they turned out to be great for, well, just about everything else.
The Transformers legacy really boils down to these four things. It delivered superior quality with higher test scores. Its parallel design made it way more efficient and faster to train. And, most critically, it wasn't a one-trick pony. This thing could generalize to other problems beautifully.
Even the authors themselves knew they were onto something much bigger. They point out in the paper that the model also worked really well for completely different language tasks, like understanding sentence structure. It wasn't just a translation tool. It was a general-purpose language understanding engine.
And that adaptability, that's the final crucial piece of the puzzle. It's the reason this single paper became the bedrock for large language models, for chatbots, for image generators, for so much of the generative AI that is completely reshaping our world. It all started right here.
It's pretty amazing when you think about it. One simple, elegant idea that paying attention is all you need was enough to launch a technological revolution. And it kind of makes you wonder, what's the next attention is all you need? What deceptively simple idea is sitting on a server somewhere right now, just waiting to change the world all over again? Thanks for watching.